or 5.8.
Like,
Analyzing graphs of polynomial functions. Okay.
it should be like a national holiday, honestly. March Madness.
If I want to graph f of x equals 1/6 x plus 3 times x minus 2 squared, okay? First, I want to follow 4 steps to graph this because this isn't something that I can just, you know how on our other graphs we looked at where the h and k is, we plotted those, we did things with the x and y intercepts, okay? Well, this is more complex of a graph, so we're going to first plot intercepts. How do you find a y-intercept of something?
You put in some form.
How do you find a y-intercept of something? What do you plug in?
A 0?
A 0 for what?
Yes.
Yes. So if I'm finding the intercepts, I need to find the y-intercept and I need to find the x-intercepts. Or there might be more than one y and more than one x, okay? So I'm going to plug a 0 in for x first. So technically this equation says y equals 1/6, 0 plus 3, 0 minus 2 squared. What is negative 2 squared?
4.
And so what's 4 times 3?
12.
And what's 1/6 of 12?
2.
2. So my y-intercept is 0, 2. Now, if I want to find x, I plug 0 in over here, right?
Yes.
And this is where it becomes a little bit more complicated. Okay? Because I have to FOIL and do all that fun stuff. Okay? If I have x minus 2 squared, that means I have... Actually, what are my x-intercepts? Can I look at that and just tell? I can look at it and just tell. What are my x-intercepts in that equation?
Energy, the opposite.
Uh-huh.
So negative.
So, yeah, negative 3,
and
0, and
positive 2, 0.
and 2, 0. All I do is take opposite of what's in here. Okay, so these are my x-intercepts. This is my y-intercept. I'm going to plot those points first. Okay? So negative 3, 0, right? Positive 2, 0, and 0, 2. Do you see how I have 3 points now plotted?
Yes.
Okay. The second step is to plot points between and beyond the x-intercepts. So I want points on this side, points in between, and points on this side. Okay? Boom, boom, boom. So I'm going to make a table. Okay? Let's make a table for x and y. X, y. Okay, if I want to plot points on both sides, all 3 segments, I'm going to plot negative 4, negative 5, negative 6. Does that make sense? I'm going to choose 3 points. Negative 6, negative 5, negative 4. Then I'm going to come in here and look. I already plotted 0, right? So let's plot negative 2 and positive 1. Does that make sense? Okay, negative 2, positive 1. And then over here, I'm going to pick 3, 4, 5. Okay? Now, let me step over here. And we'll just plug the numbers in here. Okay? Take out our x's. If this is negative 6, what's negative 6 minus 2?
Negative 8.
Negative 8. What's negative 8 squared?
64.
Okay, so 64. What's negative 6 plus 3?
Negative 3.
What's negative 3 times 64? You will need calculators on this.
Negative 192.
Negative 192. Divide it by 6 and you get what?
Negative 32.
Negative 32. Okay. Let's look at negative 5 now. If I plug in negative 5, negative 5 minus 2 is negative 7, right?
Yes.
What's negative 7 squared?
49.
Times negative 2, because negative 5 and 3 is negative 2. 49 times negative 2.
Negative 98.
And then divided by 6.
Negative 16.3.
Okay. Now let's look at negative 4.
Now can we use decimals on here, or do you want it?
You can use decimals.
Okay.
Negative 4 and negative 2 is negative 6. What's negative 6 squared?
36.
36. And then I have times negative 1, so I get...
Negative 36.
Because negative 4. Okay, negative
Wait, I have a
36.
question. Can you use any point?
Yes,
any
but
number
any
on-
points on this side, any points in the middle, and any points over there.
Any?
You have to use points from this section, and this section, but any of them, yes. And what's negative 36 divided by 6?
Negative 6.
Okay. Okay. -2, let's plug in -2. I plug in -2, I get -4 here. What's -4 squared?
16.
And then times +1,
16.
and then divide it by 6.
Uh, 2.6.
Beautiful. Plug in a +1 now, yeah? And I get 1 minus 2, which is -1. -1 squared is,
1,
and 1 times 4 is,
4,
and then 4 over 6 reduces to what?
2/3.
2/3. Then we plug in a 3. Okay, do you see how this isn't hard? It just takes time.
Yeah.
3 minus 2 is 1. 1 squared is 1. 1 times 6 is 6. And 6 divided by 6 is?
1.
Plug in 4.
Much easier.
4 minus 2 is 2. 2 squared is?
4.
4 times 7 is?
28.
28 divided by 6 is?
4.6.
And last one, we plug in 5. 5 minus 2 is 3, right? 3 squared is 9. 9 times 8 is what?
72.
And 72 divided by 6 is what?
12.
12. Okay, so I plot intercepts, I plot points. So I got this, I'm plotting my points now. I'm going to go to -4, -6, right?
Yes.
So here, 2. Okay, my other points are off this graph, so this will be good enough for me, okay? I'm going to go to -2, 2.6. So 1, 2, 2.6. I'm going to go to 1 2/3, okay? And then I'm going to go to 3, 1. And I'm going to go to 4, 4.6. 1, 2, 3, 4. So that's good enough. That will give me a good enough look at this graph. Now I determine the end behavior. Okay, what does it look like the end behavior is doing on this side?
It's increasing.
But it's going which direction?
To the right.
No.
Wait.
Well, it's yes. What is it? What are those words? It's yes. It's the end shape. Remember that chart that we looked at? You're going to need that chart again. So this end behavior is falling, and this end behavior is rising. Okay. So we draw it after that. So you're going to need that sheet to determine your end behaviors for me. Okay. And that's yes, that sheet. Perfect. So look at this graph, Cole, compared to that sheet right there, and tell me what the end behaviors are. It should be like negative infinity. Yeah.
Degree.
So this behavior is as f of x decreases, then your output decreases, and as f of x increases, then your output increases. So what it's saying is, as I put in larger x numbers, I get positive numbers out. As I put in more negative numbers, I get negative answers out. Okay? So that is what we're doing mainly today when we're graphing. You have to follow those 4 steps. There's no way around it. You're literally plugging in points, getting points out, graphing it, and connect the dots. Okay? Just follow those steps. You'll be perfectly fine. Now, the other things we need to talk about are your maximum and your minimum. Your local maximum, your local minimum. This is common sense. Whatever the highest point is on your graph is a maximum. Whatever the lowest point is a minimum. I can have more than one maximum and minimum. If you have one of these shapes, yeah?
Yes.
I have 2 minimums. Okay? If I have that M shape, yeah? I have 2 maximums, okay? So when it says identify the maximums and minimums, a lot of times you're just kind of looking at a graph, and if it's not marked clearly, you're estimating. That's fine. Estimate for me. But you're telling me, oh, here's the highest point, here's the lowest point, okay? We don't have graphing calculators, so we're not going to find the exact decimal answer. As long as you get close for me, we're good on the graphs, okay? But you need to know that maximums are the highest points and minimums are the lowest points, okay? And it's after any turning point. So you can have one that looks like this too, where it's like that. This is a minimum, this is a minimum, this is a maximum. Okay, because it turned. Every time it turns, you either have a maximum or a minimum. Okay, so minimum, maximum, minimum. Anytime there's a turn, there's one of those two happening.
Would the outsides also be?
The outsides are not maximums because they're continuing on forever. There's no longer a
Oh.
curve. It's where there's a curve is a maximum or a minimum. Okay? So any curve that you see,
So the one that's higher.
Yes.
Exceeds
so
the
anytime it
maximum.
changes direction, you have a maximum or a minimum.
So
Okay.
then,
So
if
for the
you-
one,
So this changed direction that way, there's a minimum.
Okay.
This changes back down, there's a maximum.
Okay, so I was
This
wondering.
changes back up, there's a minimum. Okay?
So there will always be two, one maximum and one minimum. For certain, there's gonna be either one.
No, 'cause there could be
no.
two maximums.
Anytime it changes direction, there is either a maximum or a minimum. So, on a parabola, right, if it faces this way, I only have a minimum,
Mhm.
right? And it's the vertex,
Yes.
okay? But on other shapes, if it changes 6 times, I have 5 different maximums or minimums.
Wait, so is there one that could be two maximums and no minimums?
Yes.
And two minimums?
Wait, 2 maximums and no minimum?
Uh-huh.
No. If you have 2 maximums, you're gonna have a minimum someplace, okay? Okay. Then the last thing we need to discuss is this, turning points. The graph of every polynomial function of degree n has at most n minus 1 turning points, meaning this. If this graph right here has a power of 3, okay, it has at least
3.
2 turning points. It's this minus 1, okay? So it's your degree
I remember that.
So
minus
N-
1.
So N stands for degree.
Yes, and in
Okay.
this case is your degree. So it has at least, it can have up to 2 turning points. Does not mean it has 2, it just means it has up to 2 turning points. If a polynomial function has n distinct real zeros, then its graph has exactly n minus 1 turning points. Okay, so we need to figure this out. We need to graph this to figure out this function and know what's happening with it. Okay, and with its turning point. How should I graph this function? What do I need to start by doing? What's the first thing I need to do?
Find y.
Find y and x intercepts, right?
Yes.
So if I plug in a 0 for x,
Yeah.
y equals 0 cubed minus 3 times 0 squared plus 6. What do you get? Y equals what?
6.
6. So 0, 6 is my y-intercept, right? 2, 4, 6, y-intercept, boom. Okay? If I plug in 0 for y, I have x cubed minus 3x squared plus 6. What do I have to do with that?
Put it in quadratic.
Well, it's a
No.
cube, right?
Yes.
Yeah, it's a cube, so can I put it in quadratic formula?
No.
No. Okay.
Oh,
Can
so-
you factor this maybe? Like something that has an x squared here and
Yes.
something that has an x here maybe? Multiplies to give me 6, adds to give me negative 3? Does that work at all?
Yes. Wait.
Well, 6 is 1 and 6 or
2 and 3.
2 and 3, so it's not going to work. Okay? So right now we can't do anything. The only thing we can do is plug in points now, yes?
That's tough.
Okay? So I'm going to plug in negatives, I'm going to plug in positives.
So just make it up.
I'm going to plug in negative 3, negative 2, 1, negative 1. I'm going to plug in 1, 2, and 3. Okay? Cool? So plug in negative 3. What do we get when we plug negative 3 into this equation? Look. We have, let me write it over here for you. Okay, negative 3. What do we plug in negative 3? Let's see. Negative 3, negative 3. What's negative 3 cubed?
Positive 27.
Okay. Positive 27?
Negative.
Oh, no.
What's negative 3 squared?
9.
And what's 9 times negative 3?
Oh, negative 27.
Uh-huh. And what is plus 6? So what's that come out to be?
48. Negative 48.
Negative
Negative 54.
7. You got what?
Negative 54.
What'd you do first? You did negative 27, negative 27 together?
That's-
Yes.
And you got negative 54.
Yeah.
And then you added 6 to it?
Oh,
It's 40,
yeah.
negative 48.
Okay, good. So I get negative 48. Beautiful. What happens when I plug in negative 2? These are large numbers. Okay, what's negative 2 cubed?
-8.
Okay. What is negative 2 squared?
4.
4 times negative 3?
Negative.
Good. Plus 6. What's negative 12 and negative 8 together?
-20.
Okay, and add 6 to it?
-14.
Negative 14. Good. Good, guys. Okay, negative 1. This should be easy. Ready, Drew? What's negative 1 cubed?
-1.
Okay, negative 1. What's negative 1 squared? 1. What's 1 times negative 3? 1 times negative 3.
Oh, 1,
Neg-
okay,
negative.
-3.
Okay, and then plus 6. So what is negative 3, negative 1 together?
-4.
Negative 4 plus 6?
2.
2. Beautiful. Okay, yes, we're almost done. Okay, 1. Ready? 1 cubed.
1.
1 squared
1.
times negative 3
-3.
plus 6. What's 6 and 1 together?
7.
And minus 3?
4.
4. Beautiful. And then 2. Yeah. What's 2 cubed?
8.
8. What's 2 squared?
4.
4 times negative 3?
-12.
And 6. What's 6 plus 8?
14.
Minus 12?
2.
And 3. Okay, 3 cubed? 27. 3 squared?
9.
9 times negative 3?
-27.
And plus 6, so what do I get?
6.
Beautiful. So, 3, 6. We plot points next, right?
Yes.
Okay, and we get 2, 2, right?
Mm-hmm.
And we get 1, 4. And we get negative 1, 2. And then negative 2 is like way down here, yes? Okay, so what's it look like turning point wise? How many are there? If I connect these dots, how many turning points do I have? How many turning points?
5.
No. Now
Oh.
how many turning points? How many, Cole?
2.
2. How many should I probably have? How many can I have up to? What tells me how many I can have up to? The degree. What's my degree? 3, and you take 3 minus,
1.
and I get,
2.
so I can have up to 2. Do I have 2?
Yes.
Yes.
I didn't catch it till like.
Okay, that's good. Now,
Wait, so it does count when there's 1 on the upside?
okay, restate that for me.
I don't.
No, it doesn't count when they're, you mean one up here?
Yeah.
No. My turning points are where?
It's the top.
We're
This
doing
part
turning
here.
points.
And then
Oh,
at the
okay.
And this
right there.
point here. So which one's my maximum and which one's my minimum?
The furthest point of top is not.
Okay, so what point is that? That's labeled, so you should be able to tell me.
0.
Uh-huh.
I think that's 6.
It is. 0, 6 is my maximum. Okay. And what's my minimum then? What is this point right here? I graphed it. It should be this one here.
2.
Yep, 2, 2. Okay. So I have a maximum. I have a minimum. My graph is a cubic function. Yes.
Mhm.
And my cubic function can have up to 2 turning points, and that's all I have. So we're good to go. Okay. Now, last thing in behavior. What's happening? As I input negative x's, what happens over here?
It decreases.
Yes. And as I input positive x's, what happens over here?
It increases.
It increases. Okay. So make sure you have that chart out with you so that you can pay attention to in behavior for me, okay? And then I need you to label local maximums and minimums. My maximum, my minimum, okay? And we're going to just graph things by plotting points today. Always start with your x and y intercepts. Got it? Okay. I will post that on